solve this problem using the method of finite differences. So we went through in the previous videos a series of equations based on taking the differential equations and applying finite difference formulas and discretizing the domain. The result was a vector of unknown temperatures based on an index I that determines position within the heat exchanger. And these red numbers are the diagonals of the matrix. So if we can program MATLAB script to generate this matrix for us, as well as this column of known quantities, then we can solve for the unknown temperatures. So here's where I think you'll see why I consider it so important to keep track of where your diagonal is. Okay, so let's get to it. Okay, so the first thing I would do is define n, the number of step sizes. Remember, the matrix is going to be 2n by 2n, so it's a good idea to start with a small number of n. The length of the heat exchanger I'm going to set to be 2. We can certainly increase that later. These are the values of the alpha constants. The inlet's temperature from stream 2 is 80 degrees. For stream 1 is 25 degrees. And h, the step size, is L over n. We're going to initially define our matrix M just as a matrix of zeros so that we only have to fill in where the numbers are not 0. So we have a 2n by 2n coefficient matrix and a 2n by 1 vector of known quantities. So the way I like to do these problems is I like to first write a for loop for all the values of I that are going to act in the normal pattern. So that refers to these two rows, right? So the first two rows correspond to I equals 0. They're not quite going to match the same pattern because you have certain temperatures involved that are known, in this case T20. The last two rows similarly are not going to follow the pattern because you're at the other end of the reactor, and in this case T1n is a known quantity. So everything other than the first two and the last two rows should follow the same pattern. So I'm going to start there, and then later I'm going to come back and fill in the terms for I equals 0, and then I'm also going to fill in the terms for I equals n minus 1. And when I'm done with this, I'm going to have a definition of M and B, so I can solve for my t vector just using MATLAB's built-in functionality. Before we can run it, we have to actually define the matrices. So again, I'm looking here, and it helps to think about the correspondence between I and the row of the matrix as MATLAB would see it. So let's look at the smallest value of I. It has to be greater than 1, so the smallest value would be 1, and that would be row 3. So in fact, we're going to be looking at row 2i plus 1. I'll fill in the rest later, and we're going to be looking at 2i plus 2. So this would be row 2i plus 1. This would be row 2i plus 2. And the columns, notice here that that's the diagonal. So you start one before the diagonal, one column before the diagonal, and you end one column after the diagonal. So that means 2 times I, comma, 2 times I plus 1, 2 times I plus 2. Remember that if this is my row number, 2i plus 1, then the diagonal is going to correspond to the column number that matches the row number. And let's fill in what we actually put in there. 1 plus alpha 1 times h minus alpha 1 times h minus 1. Then here, the we're going to start 2 before the diagonal, so that's going to be 2i, 2 times I plus 1, 2 times I plus 2, right? That's the diagonal, and then 2 times I plus 3. That's 1 after the diagonal. Remember, if that's the row, that's the column that we have in the diagonal. And this is going to equal alpha 2 times h, 1 minus alpha 2 times h, 0, negative 1. Okay? So these should be very similar for the first 2 rows, but not exactly the same because some things were actually moved. So I could go in and delete all these 2i terms because I is equal to 0, but I'm not going to do that just because I don't have to. I is equal to 0 here. So now we're looking at these 2 rows. Okay, so we don't have a 2i term. We have we start at 2i plus 1, and then we go to the next one over, and over here we have a 1 plus alpha 1h and then negative 1. So this term goes away. And then over here, again 2i plus 2, we're going to start 1 before the diagonal. That's going to be oh, I'm sorry, no. 2i plus 2. Okay, so this actually is going to be, oh, actually that is right. So we're going to start at 2i plus 1, and then we're going to go to 2i plus 2, and then 2i plus 3, and this is going to be alpha 2h, 0, and negative 1. So let's see, 2i, so that's row 2, row 1, row 2, column 1, column 2, column 3, alpha 2h, 0, negative 1. That's right. Okay, so again, I can use this as a template. Actually, you know, I'm not going to use this as a template. So in fact, here, I'm not even going to remember that I is equal to n minus 1 because I want to show you a different way of thinking about it. We know that this is row 2n and this is row 2n minus 1 because we know the dimension of the matrix. So I'm going to say m of 2n minus 1, comma, 2n minus 2, and 2 times n, I forgot the times here, 2 times n minus 1 is going to equal 1 plus alpha 1h and minus alpha 1h. Okay, so 2n minus 1, 2n minus 2, this is actually going to be 2n minus 1. Okay, so that is these positions right here, and m of 2n, comma, 2n, keep forgetting the multiply, minus 2, 2n minus 1, 2n is going to equal alpha 2 times h, 1 minus alpha 2 times h, minus 1. Okay, so that completes the matrix, but we have not actually completed the terms that are constants right here. So here I'm going to say Sorry, FaceTime call. Okay, I hope that doesn't keep happening. B of 1 comma 1 is going to equal alpha 1 times h times t2 0, and b of 2 comma 1 equals alpha 2 times h minus 1 times t2 0. Okay, here b 2 times n minus 1 comma 1 is going to equal t1 n. Okay, so this should solve for the temperatures. I have now populated M and B correctly, so why don't we try that out? I need the MATLAB editor, so let's see how this runs. First of all, let's see if it runs. Okay, it did something, but I don't have any output. Okay, so I've got a vector of temperatures. I don't know if that's right or wrong. So we've got to unpack it and plot it. Okay, so let's go back over here and remember that the first 3 numbers here are going to be the T1s, and then we alternate T1 and T2, and then the last 2 numbers are going to be T2. So this is going to be a little tricky to actually unpack our temperatures from here. So let's say T1 series. First of all, I'm going to transpose the T vector so I can unpack it more easily. So the T, it's going to be T vector. So the first 3 numbers, so 1 colon 3, and then 4 colon 2 colon n minus 2. Okay, and let's put, so we know T1n is at the end. Okay, the T2 series equals T vector Okay, so we're going to start off at position, oh wait, this is not, that shouldn't be 4. So 1, 2, 3, and then 5. Okay, so this will be 4 colon 2 colon, I'm going to guess it's n minus 1, n minus 1. And then we can put position n there, and we need to tack on T20 here. So I'll be surprised if that's right. T1 series is 1. Well, let's play with it. So your X series equals 0 colon H colon L. And now let's plot X series, T1 series, X series, T2 series. Okay, we got a problem. On line 35. What's your problem? Invalid expression. Oh, I think I need commas here. Okay, vectors must have the same length, so that doesn't surprise me. Let's see what the lengths are. Okay, so X series goes from 0 to 2, so that's 11 of them. And this is not getting the right number. Let's see. What is the size of the t vector? Okay, so that is the right size. It's 1 by 20. Okay, so we're going to go to, oh, this should be 2n minus 2. And this should be 2n minus 1. And still not sure that's right, but let's see how that goes. Okay, so the temperatures don't look too bad. These do. That doesn't look right. So I think I am shifted a bit. So this is the right size. This one is not. T2 series is not the right size. So T2 vector for, so let's see, 1, 2, oh, yeah, sorry, I fell for this earlier. So this T1 of I, when I is equal to 1, that's actually the same thing. So the first T2 is actually row 3, not row 4. So you have 1, 2, and then 3. So this should be 1, 2, and then 3 colon 2. And this should be, maybe that's right. So maybe that should be 3. Okay, so it's looking a little jagged, but perhaps that's because we don't have the right or enough small steps. Let me check that out. Let's make this 100. Well, that looks better, but there's still a glitch here and a glitch there. So I have a feeling I'm still not quite plotting the temperatures right, but so that this video doesn't end up too big, unless I can find the mistake quickly, I may just have to post the correct script and apologize for not having this worked out on the video. But let's give it some labels. X label. So this is going to be X, and Y label, stream temperatures. And let's put a legend. So T1, T2. Okay, I'm still pretty sure I got something wrong. So this comes in at 25, that goes to 80. That's not bad, but this discontinuity suggests that there's something wrong with the equations entered. So let me just see if I can clarify these equations. Alpha 1. that should be alpha 1, not alpha 2. I don't know if that's enough to fix the problem, but let's see. Still a bit problematic over here. I wonder if that's actually in the last row. Let me check. Let me review that. 2n. No, I don't see a problem there. T vector. Oh, yeah, this is a problem. 2n is the last member of the T2 series. Ah, there it is. Looks like that's right. Wonderful. Thanks for watching that.